This is the last part 3 of this video. Let's look a little bit on the plug-in modules. If you look at the 4 holes here on the top of the connector, they fit or they align to the bottom side here, where you also see 3 holes. So the whole idea, as far as I remember, is that you can glue in some plastic pins in here, and this way you can code your modules so that you cannot plug in the wrong modules. And in this case, everything here is removed, and that means you can plug in anything you want. Let's look a little bit on the analog plug-in modules. The modules in this digitizer, they're called a 7A16P programmable amplifier, and they are specially made for the 7612D programmable digitizer. They're using a modified 8-bit bus, the HBIB bus, on this internal mainframe connector here to control all of its settings. And those modules here, they run on negative 5.2 volts, while normal scope plugins run on a positive 5 volt. And this one will actually, if you plug this into a normal scope, it will short circuit the 5 volt supply in your scope. So you shouldn't interchange those modules, but they're definitely exactly the same mechanical layout. So it's super tempting to try and do that. And I think that was the intention with the coding here, so you could not do that, but this is not present in this one. By the way, I will put in a link to the Tech Wiki page where you can read all the details about this plugin module, by the way. But meanwhile, I can show you how it looks like in the inside here. It is using another 6800 CPU. We got RAM and ROM and interface ICs here, the 6821 they're using for controlling all the different logic and the signal path of all the different selections. It's not a whole lot of different features you can do here. You can of course change how many volts you want per division, and you can change the polarity, and you can change the bandwidth between 20 megahertz or full. And full is 200 megahertz, by the way. It looks a little bit confusing about the A and B inputs here. You could probably think, oh, this is differential or some sexy stuff, but that is not the case. It is just 2 different inputs, and you simply just select which one of the 2 inputs you're using. You can either do it by pressing this switch, or you can of course do it on the bus AC or DC mode. You can ground, but this one is very special about you have 50 ohm or of course 1 mega ohm input. And you can calibrate your gain here, and you have of course variable, and you have a position. So that is more or less all there is about it. Yes, of course it contains quite a lot of custom ICs. Here's another custom tech chip. That one. And I believe that one is also a custom tech chip. And on the other side, yeah, let's have a look. On the other side here we have of course the input and the amplifier for the input stuff. That one says, ooh, delicate board-in material. So I'm not opening that. It looks like it's a regular FR4, but it could also be Teflon. Yeah, we got all those transistors here that's doing different selections of stuff, driving the LEDs. And that will be high-speed amplifiers. Again, special tech ICs, and by the way, they're in sockets, and two of them, they were halfway out of the socket, so I had to push them back into the socket. You can probably see here, this one is still not all the way in, but it's a pretty nice socket. So those tiny little gold pins here, they're soldered into the PCB, and there you have it with the sockets. We got some internal coax cables for high speed, and that's the backplane connector. Oh, there's also a shield between the two boards. It's also made of a printed circuit board, of course. So yeah, now I'll go and put this back together. I didn't see any leaked capacitors here. I'm totally on the hunt for something that should prevent me from booting up this unit, but I cannot find any reason why I shouldn't go and proceed with that. So here we're looking at the Deflection amplifier, and this big board here is sitting right next to the two CRTs. They're inside this metal case. So I believe that will be the differential channel A input, and it goes all the way to the CRT with those wires directly through the board going into the CRT, and it's of course the same with the channel B. And then we got some outputs from this unit, from this amplifier, and they are delayed using a delay line. See, this is the orange and the yellow. And let's see if I can show you this. But here is a delay line, and this goes back to the data memory for both of the channels. I haven't yet figured out exactly what is the point with that, but that is how it's done. It's probably for the triggering or something like that. We also have a lot of different deflection plates to steer the beam to the pickup array. There's a special silicon diode array with 10 detectors at the end of each of the CRTs, and of course you need to hit exactly those pickup diodes. So we got different steering deflection plates. So that is what is happening here. You have to adjust all those things, and then it says, "Oh, danger, lethal voltages and all that," and it's only 130. Ooh, you're scared, aren't you? And the deflection board is made in 1978. And yeah, what else can I say? We got a lot of connectors here, so I really would like to see if I can take away this board and get into the CRT section, because that is definitely what I came here to see. So I have to mark all those connectors. They got different colors, but I think the colors are a little bit difficult to read now. You can see they're orange, and this is yellow, and those are the two channel signals. But luckily they all go the same direction. They count from top to bottom, and all that is nice. So I should be able to figure this out. And then we got some wires, some connectors, and all those wires here, and then they go to the end of the CRT. Some of the other stuff down here, and it also goes to the high voltage section. So down here we have in this unit here, that is the high voltage cathode supply, and that one is supposed to be, well, you can take it out, I guess, by just removing those screws here and pull it out. So that is what I would like to try and do. So I'm still trying to get in here. I was able to pull out the power supply a little bit, and I actually found something that's really cool. So this is the back side of all the BNC connectors, and you're gonna love this. See, each of those cables, there's actually a little connector here on the back, so you can pull them out. Clickety click, easy easy. So I marked all the different colors here because if I'm going to pull this, I definitely want to connect it all correctly again. But I have a little stuck kind of problem. So we got some wires for the high voltage stuff here at the back of the tubes. Now let me show you this. The tubes are actually a lot bigger than I had the idea they would be. Look at that one, it's quite big. So that's real nice. And here is my hand for measures. So yeah, so those are really, really nice tubes. But you see all those wires here, how can I disconnect all this? And it goes directly into the high voltage power supply. And I believe we got one transformer and two trippers or something like that. See, there's one up there and there's another one here or something like that maybe. That will be the two different focus potentiometers. See, they isolated this really, really good because it's probably hanging a few thousand volts away from chassis. We got some control and power here to drive all the high voltage. So what I think is the idea here, I've been looking a little bit on the exploded view on both on the high voltage supply. There's also some drawing that shows all the different parts and what it is made of. And then I was looking at the exploded view drawings for the CRT assembly, and that is also a little bit confusing. How do I need to what do I need to pull apart here? So I think that I want that screw, right? And there are a few more of those. So I really want to take away the entire deflection board. And to do that, I also need to take away all those connectors. So I'm starting to mark the different connectors and the different coax. So I should be able to get in there because I want to see those CRTs. So here's the deflection board. I was able to get the darn thing out. It was a little bit difficult, but that board is definitely amazingly designed. Of course it is a, what is that, 3, 4? It looks like it's 4 or 5 layers. I don't understand exactly what's going on here. There's a bigger room for something here, but it's only 4, right? Yeah. Only 4 layers. We got quite a lot of modifications and stuff. It's a little icy here and whatnot. Ooh, they've been optimizing the last little picofarads here and there and funny things, cutting tracks, and ooh, it's better to do it like that, and oh my god, a lot of modifications. And also note the internal layers, how well they are organized here. We got some signals here, we got some grounds there, and especially here we got many different layers of doing fancy things. Yeah, definitely some high tech. And down here is just the DC deflection adjustments and all that kind of stuff. Not super high speed or anything down here, but still they're trying to isolate stuff using the different ground planes and all that. I also think I found some problems with leakage or isolation and stuff. Yeah, see, that is the deflection. This is access into the CRT. I don't know if you can see it here, but we had some leakage problems, but they're also using metal washers underneath the nuts here. So that means the distance to tracks and voltages, they're like critically small. And see that track there is super small distance. You can even see some leakage problems down the connectors. I also got a little bit of corrosion issues on all over the different connectors here, as you can see. So that could explain some of the problems they had. I tried to clean it a little bit here, but all those connectors on the gold, it was full of corrosion and nasty stuff. So, and it's also inside my connectors. I don't know what's gonna happen later when I try and power this up, but I really want to go inside the CRT section here. So let's see if I'm able to get further in here. I should save those two ferrites. They go on the two inputs here. So if I put them there, I'll probably remember them. So to get in here to see the two tubes, I had to, of course, remove this metal plate, and to get that out, I needed to access the front screw, that one, through that hole, right? Otherwise there was no way to get in here. So to get in there, the only way to access this bad boy here is to take away the entire front plate. They are really trying to make it as difficult as possible. But of course, the more difficult it is, the more fun I have the whole day. I have a lot of corrosion issues, as you can see here. So that made me a little bit sad. But the board looks quite alright, good health. Look at that. Bulbs, real bulbs behind all the switches. Isn't that just beautiful? So I bet they shine really, really nice and beautiful. And here we got the 7 segments for all the indications. So they're soldered in. And that's all. That is what it takes to handle the entire front panel with all the switches and all the lights. And that is, of course, you can see all that in the 7 segments. And that is, of course, because we got a lot of drivers and stuff like that, probably serial controlled and all that. And again, nice connectors behind the BNCs, so this is easy to take apart. So now we are in here, in behind the front, so that makes it possible to look at the end of the two CRTs. And here we go with the pickup diodes. They're behind that one. We got some other nice and special white ICs. I can't really get in here because of all the wires. This makes it difficult to video this. But a very, very nice and special circuit board here. Definitely. Whoa, have a look at that, huh? So the two blue coax cables that goes to both of the modules here, that is a balanced 200 megahertz clock, because it's sampling in 200 megahertz. So we've got a 200 megahertz oscillator here. This is running on minus 5.2 volts, and we've got the balanced drivers for all that. Maybe I should show a schematic or something like that. Maybe I will do that if I remember to do that. But yeah, so that is a nice way to hide away that board, and it's of course nicely shielded behind that piece of metal and all that kind of stuff. Yeah, this is by the way, external and internal clock in and out that goes to the rear panel, and you can of course select if you want to use internal or external. I also figure out the way to take away the high voltage power supply. So what I should have done if I wanted to take away the entire high voltage power supply, just unconnect the high voltage stuff here, and that will be the focus stuff, and then just unplug each of those connectors for the CRT. And then you see all those cables here. There's like no other connectors or anything. They go straight into the power supply. So that is the only way to do it. Here we got the nicely high voltage cables. But I got a very, very sad news. Just before I started this video clip, I've been yelling and screaming and giving you all the bad swear words I could possibly imagine, because I got very, very sad news. And let me see if I can give you this on the video. Can you see the crack here in the glass? So this crack go all the way around the CRT here. So this CRT here is completely broken all the way around. We got connectors. We got a few more connectors down here, I suppose. Here you see. So this is where it's cracked. And then I thought, maybe I'm lucky with the other one. But look at that. I don't know if can I get... Yes, here you go. See? The same damn crack all the way around. If only I knew this a few days ago, then I shouldn't have wasted 3 days repairing the damn power supply. That is just the worst kind of news that you can come with right now. So there's no way I'm ever going to get this up and running. What a bad, bad day, folks. I am so sad about that. But the good news is that now you can have a look at everything here, but I really wanted to get this back and show you some really cool things. Sad. I didn't actually plan to go all the way in here, but now the tubes are broken, so I might as well try and get all the way in here anyway. It doesn't matter. Nothing matters anymore. Nothing matters. So how are we going to disassemble this? I think this is a copper shield. At least it is possible to solder on it somehow, because they had a cable soldered to it here, right? You can even see here that this one was thrown, which is really sad. I hate when people throw trash. Why can't they just put it carefully in the container so all us container hunters can find cool and fun things to play with? What a sad day. But I'm going in here and let's have a look what it is and how it is all assembled, at least. Maybe it's just like that. So that was real difficult. So this is how it's assembled. Oh, it's actually even cracked in here. So we got those two screws here. It's supposed to be cracked. So the idea is you screw this in here. See, it gets bigger and bigger. See? And this way it will get itself like real tight here in each end. So that is how this lock is working. So here's the trace rotation coil. And we got all the different deflection and focusing systems and all that kind of stuff here. Oh, we got a lot of really nice and beautiful things. And you see the crack is really nasty all the way around. And I'm really trying not to lift the tube too much because it's gonna fall into two pieces here, which is going to be really, really sad. As you can see here, it's completely cracked all the way around. Oh no, it's so sad. But if you try and ignore the crack, it's a beautiful tube. Wow, definitely something to keep. Just to have a look at it. Whoa, this has been expensive. I just can't stop looking at this beautiful, beautiful tube. I try to clean it up a little bit so you can see a little bit more of its beauty and its details. What I really cannot figure out is, why are they still black? Because there's definitely a crack, and you see the crack is not even, it's like that. So how can you have a crack in the glass and it goes all the way through? I can even feel it. So the glass is cracked. So I really don't understand how that is possible. Looks like there's still vacuum inside the tube, or at least this black vacuum creating substance in there is still black. So that is a little bit weird. But anyway, thank you very much for watching. This is end of part 3.